Hey everyone, it's Miss Mac here with another short video, this time about multiplying and dividing powers. This is the first official lesson of our new exponents unit. If you're feeling like you need a review of exponents and how they work, go ahead and watch our review exponents video before watching this one. We have two learning objectives for this video. The first learning objective is that we will be able to use the laws of exponents to multiply powers of the same base. And our second objective is that we will be able to use the laws of exponents to divide powers of the same base. So in order to illustrate the laws of exponents that tell us what to do when we multiply or divide powers of the same base, we'll be looking at some examples together. First, let's see what happens when we multiply powers of the same base. On the left-hand side, you can see our first example, which says 2 to the 6th power times 2 to the 4th power. So we've shown what this looks like in expanded form. Let's count how many times we multiplied 2 by itself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the simplified power that I would write over here is 2 to the 10th. Let's see what happens when we multiplied 3 to the 4th times 3 to the 2nd. That's 3 times itself, 1, 2, 3, 4, 5, 6 times. So that's 3 to the 6th power. Next, we were given an expression in an expanded form, and we need to figure out how many times or what exponent goes over here on the left. So we have 1, 2, 3, 4, 5, 6, 7 times. That 4 has been multiplied by itself. We already have one of those times here, so we must have had 4 to the 6th power here. And our simplified power would be 4 to the 7th power. That's how many times we counted the 4s being multiplied by itself. And in our final example, we know we're going to end up with the simplified power of 5 to the 3rd. So if we already have 5 to the 2nd, which is 5, times 5, then we must have had 5 to the 1st power here. So now I want us to think about all of the expressions we had to the left and the simplified powers that we had to the right. So over here on the left, if I were to add together 6 and 4, that would give me 10. Which is what I ended up with over here. And if I were to add together 4 and 2, that would be 6. So that's what I ended up with over here. So I notice a pattern that's starting to happen. 1 plus 6 is 7, and 2 plus 1 is 3. So let's try to generalize a rule for what happens when we multiply powers of the same base. The rule that we can write when we multiply powers of the same base is that we will be able to add the exponents. So when we multiply powers of the same base, we add the exponents. So pause this video for a moment and make a prediction for yourself. What will happen if we divide powers of the same base? What will we do with our exponents? Well, let's look at an example of that here. In our first row of this table, we have 2 to the 6th power divided by 2 to the 4th power. When we're dividing in expanded form, we can cross out pairs that we see in the top and in the bottom. So I see a pair here. They cancel out because 2 divided by 2 is 1. So those 2 would cancel out. I see another pair, and another pair. What I have left is 2 times 2, and 2 times 2 is 2 to the 2nd power. Let's see what happens in our next example. We have 3 to the 4th divided by 3 to the 2nd. So we can cross out pairs, and we have 3 to the 2nd power. Now in our third example, we need to write this expression in expanded form. So in the numerator, we have 4 to the first power, which is just 4. And in the denominator, we have 4 times itself 6 times, or 4 to the 6th power. So in this example, there's only one pair that we can make between our 4s. And we have more numbers in the denominator than we do in the numerator. So we have powers left in the denominator, but none left in the numerator. So this 4 divided by this 4 actually leaves us with just a 1 in the denominator, or in the numerator. And because we have all of these exponents or these powers downstairs, then the exponent we will use is actually going to be a negative exponent. So we will have the exponent 4 to the negative 5th. And in our last example, we have 5 to the 2nd power, 5 times 5, divided by 5 to the 1st power, which is just 5. So we have one pair that we can make, and we're left with just 5 to the 1st power. So just like when we were multiplying, I start to see a pattern happening here. If I take 6 and subtract 4, I get 2 to the 2nd power. If I take 4 and I subtract 2, I get 2, so I have 3 to the 2nd power. If I take 1 and subtract 6, I get negative 5, so that's 4 to the negative 5th power. And finally, 2 subtract 1 is 1, so 5 to the 1st power. So maybe you made this prediction before we looked at those examples, and maybe you said that when we divide powers of the same base, we will subtract the exponents. All right, everyone, if you still have questions, go ahead and watch that video one more time. And if you're struggling, send Miss Mac an email. If you liked this video, don't forget to hit the like button on your way out. And of course, if you haven't already subscribed to our YouTube channel, go ahead and subscribe now. Thanks for watching.